In this pencast, we'll be talking about finding areas. We're asked to find the area of each figure, and we're given a graph of a parallelogram with internal lines drawn. We're given A to be the point 1, 1, B to be the point 6, 1, C 8, 1, D 10, 1, F 3, 4, J 8, 4, and K 12, 4. The first thing we're asked is to find the area of the parallelogram ABJF. So that's going from A to B, up to J, and over to F. So it's the parallelogram that is shaded here. The thing to remember is the area of a parallelogram, oops, it's a bad parallelogram, sorry, equals base times height, where height is the vertical height. So basically, if we have a parallelogram here, this is the base, and this line right here is the height. So we can do that by doing the distance formula. We're looking for the length of line AB on the x-axis. So the point A is at 1, 1. Point B is at 6, 1, which means that the distance between them is 5 because of 6 minus 1. So B equals 6 minus 1, or 5. The height, F is at the point 3, 4, and the height is dealing with the y-coordinates. So we go from 4 all the way down to this line, AB, which is on the line y equals 1, so 4 minus 1 equals 3. So that's just done by looking at the coordinate points and figuring out if we're looking at the x-axis or the y-axis. That means that the area, or A, is going to be B times H, or 5 times 3, which is 15. Since we don't have any units, we can just either leave it as 15 or we can write units. 2, we're asked to find the area of the triangle BCJ, which is going to be this triangle here. Remember that the area of the triangle equals 1/2 the base times the height. The base of this triangle is line BC. And let's see, since we're looking at the length, or the length of the base, we're looking at the x-coordinates. For B, we're at the point 6, 1, and for C, we're at the point 8, 1. So the length equals 8 minus 6, or 2. If you were to do, for some reason, 6 minus 8 and got negative 2, all you would do is realize that there's no such thing as a negative length, so you just need to switch the sign into a positive sign. It's always going to be positive when you're looking at lengths and areas. So know that the base is 2 units, and the height is going to be the line JC. Since this is a parallelogram, we know that the top line and the bottom line have to be parallel, so we can use the same height that we had from before, which is 3. That means that the area is 1/2 base times height, or 1/2 times 2 times 3. The 1/2 and the 2 multiply together, giving us 1 times 3, which is just 3 units. 3, we're asked to find the area of AFJD. Since this is no specific shape, what we're going to want to do is break this up into shapes that we know how to find the areas of. We already found the area of the parallelogram AFJB, or ABFJ, and we already found the area of the triangle JBC, which was the second one. So all that's left to create the shape we're looking for is the area of the triangle JCD. So we know that the area of AFJD equals the area of parallelogram ABJF plus the area of the triangle JBC plus the area of the triangle JCD. So we know that the area of the parallelogram is 15. The area of the triangle is 3. And now we just need to find the area of triangle JCD. We know that that is going to be 1/2 the base times the height. The base is going to be the x-coordinate of D, which is 10, minus the x-coordinate of C, which is 8, times the height, which we already know is 3, which becomes 1/2 times 2 times 3, which becomes 3. So we know that the area of this entire shape is 15 plus 3 plus 3, or 15 plus 6, which is 21 units. Next, we're asked to find the area of the shape BJKD, which we know the areas of the triangle BJC and JCD, so we know that this is just going to be JBC plus JCD plus JKD, which means that it's going to be 3 plus 3 plus 1/2 the base. Now the base this time is the length of JK. So looking at the x-coordinate of K, we have 12, minus the x-coordinate of J, which is 8, times the height, which is still 3, gives us 6 plus 1/2 times 4 times 3, which is 6 plus 6, or 12 units. And last, we're going to cram it in the corner here. Sorry about that. We're looking for the area of AFKD, which is the entire parallelogram. And since areas add, all we have to do is add up the area of the parallelogram AFJB, the triangle JBC, the triangle JCD, and the triangle JKD, which we've done in the subsequent parts. So we know that this area is going to be AFJB plus JBC plus JCD plus JDK, which we know is 15 units plus 3 units plus 3 units for JCD, and then plus 6 units from the JDK, which we got from over here, which means we're going to have 15 plus 6 plus 6, which is 21 plus 6, or 27 units. And that's how you're going to solve the area for figures and figures within figures.